The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to section 10.4, the first part of it. But before we do that, are there any questions from anyone concerning previous assignments? If so, now is the time to speak.
Yes, can we go over on the last assignment for yesterday on number 3?
Hang on. Okay. Let's see here. So 10.2 part 2?
Yes.
Okay. And which ones, whatever?
I am stuck on number 3, but if you can work on number 3.
3, okay. All right, let's take a look at number 3. All righty. A huge suspended LED screen is the centerpiece of the place, a popular mall in Beijing, China. Find the length and width of a similar rectangular screen if the length is 10 meters more than 4 times its width, and the viewable area is 8550 square meters. Okay, so we've got this rectangle, and we know that the area is 8,550 square meters. It says the length is 10 meters more than 4 times the width. Okay, so if the width is x, the length would be 10 more than 4 times x, or 4x plus 10. Okay, I'm going to switch back to my whiteboard screen. So we know the area is 5550 square meters. The length is 10 more than 4 times the width. So if the width is x, the length is 4x plus 10. Are you okay with that so far?
Yes.
All right. Area of a rectangle is length times width. So 8550 equals 4x plus 10 times x. Okay. So 8550 equals 4x squared plus 10x. We want to put this in standard form. I'm going to move everything to the right so that my leading coefficient, the 4, is going to be positive. So I'm going to subtract 8550 from both sides. So 0 equals 4x squared plus 10x minus 8550. Okay, so everything's even, so I could cut it in half. Do you want to reduce it down or leave it as it is? Your choice. Yoo-hoo!
Can we reduce it?
Okay, so I'm going to take a 2 out of everything. So I'm going to divide by 2, divide by 2, divide by 2, divide by 2. So we get 0 equals 2x squared plus 5x minus, let's see, what's 8550? 8550 divided by 2 is 4275. Okay, so that means that A is 2, B is 5, and C is negative 4275. Let's write that a little nicer. C is negative 4275. Okay, so x equals negative b plus or minus the square root of b squared minus 4a C. Okay, all over 2a. So x equals -5 plus or minus the square root of 25. So I've got -4 times 2 times -4275. Negative times negative is going to be positive. Okay, 4 times 2 is 8. So then 8 times 4275 is going to be 34,200 all over 4. So x equals -5 plus or minus the square root of 34,225 all over 4. Well, let's hope that 34,225 is a perfect square. So I'm going to take the square root of that, 34,225. It's 185. Excellent. So x equals -5 plus or minus 185 all over 4. So far, so good?
Yes.
Okay. So now I'm going to take this information and go to the next page. So x is -5 plus or minus 185 all over 4. So x is -5 plus 185 over 4, which would be 180 over 4, which would be 45. Or x is -5 minus 185 over 4, which would be -190 over 4. And frankly, I don't care what that is because we're looking for distance. This is going to be negative. So my only answer is going to be 45, and that is meters. So the width is 45 meters. The length is 4 times 45, which is 180, plus 10 would be 190 meters. So the width, 45 meters, the length, 190 meters. You okay with that? Any questions, anybody on that one?
Okay.
All right. Any others that you want to look at? Anybody? All right. Then we will go on to section 10.4. I'm a little bit stressed this morning because some of the things that are supposed to be working aren't working the way they're supposed to be. And so we'll see what happens, but okay. So just bear with me here because I'm going to have to switch screens several times to do what I want to do here. So we'll see what happens. Okay. And all right, so I'm going to stop sharing. And now can you see the screen? It says f of x equals x squared over on the left-hand side.
Yes.
Thank you. All right. Today we are going to be graphing second degree or quadratic equations. And so I want to just look at a basic one and we'll build from there. So if I have f of x equals x squared, which is the function notation for y equals x squared, I'm going to graph this. Now, whenever I'm graphing something that I'm not familiar with, I am familiar with it, but let's suppose I'm not, I'm going to use x values going from -3 to +3, just as a starting point, see what that gets me, and then if I need to change things, I will, okay? So for this particular graph, if x is -3, f of -3 would be -3 the quantity squared, which is 9. If x is -2, f of -2 equals -2 the quantity squared, which is 4. Notice I'm squaring the whole thing, including the negative, because this says x squared, the whole thing, okay? If x is -1, f of -1 equals -1 the quantity squared, which is 1. If x is 0, f of 0 equals 0 the quantity squared, which is 0. If x is 1, f of 1 equals 1 squared, which is 1. If x is 2, f of 2 equals 2 squared, which is 4. If x is 3, f of 3 equals 3 squared, which is 9. Okay, now let's take a look at just my table here. Based on this table, is this a function or not? Yes, it is. We've got two different x values, let's say -3 and 3, both going to the same y value. That's okay. Two different inputs can go to the same output. It's when you have an input going to two different outputs that it's not a function. So this is a function. But there's also some kind of symmetry going on here. These have the same y value, those have the same y value, those have the same y value. Let's see what that looks like graphically. Okay, so -3, 9 would be right there. -2, 4 is right there. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Now, obviously, this is not a straight line, is it? This is not a linear equation. And let's see if I can make a graph of this thing. I've got this curve that I'm trying to use. And we'll see what happens. Close. Not a perfect fit. I've got this thing I'm trying to use here, but let's see here. Let's just do it free-handed, see what happens. Yeah, not too bad. All right, so there's the graph of f of x equals x squared. I want to point out some important things on the graph, okay? Notice there's symmetry. There's symmetry about what is called the axis of symmetry. In this case, the axis of symmetry, let's see here, is right here. It's the y-axis. Okay, can you see that the graph is symmetric about that line? So we'll say that the axis of symmetry is at, what would that be? That would be x equals 0, because the equation of a vertical line is x equals a constant. Y equals a constant is a horizontal line. Okay, we covered that the other day, but x equals a constant is a vertical line. So the axis of symmetry is at x equals 0 for this thing. Okay, now this point right here is called the vertex. When a parabola opens upward, which is what this one does, the vertex is the lowest point. If we look at a parabola that opens downward, let's say it opens like this, then the vertex would be the highest point. The vertex also lies on the axis of symmetry. Okay, so we've got the graph of what is called a parabola. Parabola. Okay, that's the graph of a second degree or quadratic equation. It has this sort of horseshoe shape or tongue shape, whatever you want to call it there. Okay, it either opens upward or it opens downwards. There's an axis of symmetry of a vertical line about which this thing is symmetric. Okay, there's a vertex, which is either the lowest point in this case or the highest point if it opens downward, and it lies on the axis of symmetry. Okay, lots going on there. Any questions before we go on? Okay, let's go to the next example. So here we already have the graph of f of x equals x squared, and we see it over here. Okay, now let's take a look at f of x equals x squared plus 3. So we're going to square the input and then add 3. All right, so let's see here what that's going to look like. So f of -3 would be -3 squared plus 3, which is 9 plus 3, which is 12. If x is -2, f of -2 equals -2 squared plus 3, which is 4 plus 3, which is 7. If x is -1, f of -1 equals -1 the quantity squared plus 3, which is 1 plus 3, or 4. If x is 0, f of 0 equals 0 squared plus 3, which is 0 plus 3, which is 3. If x is 1, f of 1 equals 1 squared plus 3, which is 1 plus 3, which is 4. If x is 2, f of 2 equals 2 squared plus 3, which is 4 plus 3, which is 7. And finally, if x is 3, f of 3 equals 3 squared plus 3, which is 9 plus 3, which is 12. Okay, notice some things. Notice there's still some symmetry with the values. How do these y values compare to those y values? Can anybody tell me? The red ones, how do they differ from the black ones? No one wants to participate? Fine. Okay. There are 3 more. The y values over here are 3 more than the y values over there, which should make sense because what are we doing? We're putting the same x value in and squaring it. Okay, that gives us these first values, which are just like these, but then we add 3 to the y. So we get y values that are 3 more than the original, f of x equals x squared. Well, if all the y values are 3 more than they were before, but the x values are the same, what is that going to do to the graph? It's going to move everything up 3 units. So this point is going to go up 3 units. This point is going to go up 3 units. This point is going to go up 3 units, up 3 units, up 3 units, up 3 units, up 3 units. Okay? And just in case you're not clear on that, isn't that -312, -27, -14, 0, 3, 1, 4, 2, 7, and 3, 12? And let's see what our graph looks like. It's got the exact same shape, but everything's moved up 3 units. Notice that for this one, the vertex is at 0, 0. But for this one, the vertex is at 0, 3. Okay, everything moved up 3 units, including the vertex. Okay. Any questions on this example? All right, let's take a look at this one. So once again, we have f of x equals x squared in black, graphed over here. And now we have f of x equals x squared minus 4. So the new y values, how are they going to compare to these y values over here? Is there a way we could shortcut it and just get to the outputs without doing each calculation? Anybody? Okay. Well, all right. Is anybody even still there?
Wouldn't it be 9 minus 4?
Yeah, thank you. You'd subtract 4, wouldn't you? 9 minus 4 is 5. 4 minus 4 is 0. 1 minus 4 is -3. 0 minus 4 is -4. 1 minus 4 is -3. 4 minus 4 is 0. 9 minus 4 is 5. Now, if you want me to, I'll go through it the long way. But the first part is going to be exactly like this. And then you're going to subtract 4. So 9 minus 4. 4 minus 4, 1 minus 4, 0 minus 4, 1 minus 4, 4 minus 4, 9 minus 4. Okay? So now, with the same x values, the new red y values are 4 less than they were before. So what is that going to do to the graph? Recall that here, a +3 moved the graph up 3 units. So what's a -4 going to do? What?
Gonna bring it down to negative.
That's going to bring it down 4 units. Right. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And just to verify, -3, 5 is right there. -2, 0. -1, -3. 0, -4. 1, -3. 2, 0, 3, 5. Same shape, but it's shifted down 4 units. Where's the vertex? Well, for f of x equals x squared, it's there. For f of x equals x squared minus 4, it's at 0, -4. Okay, so let's review. F of x equals x squared, the vertex, I guess I should have written it. Vertex is at 0, 0. Okay. For f of x equals x squared plus 3, it moves up 3 units, so the vertex is at 0, 3. X squared minus 4, everything moves down 4 units, so the vertex is at 0, -4. So by putting a constant outside of the x squared, it moves the vertex, it moves the whole thing, either up or down. Okay? Now, let's take a look at this, and now we're going to have a -2, but it's not outside, it's inside the square. Okay? So what I want to do with this first table that's right here, this table, I'm going to plug in those x values into the function and see what happens. Okay? So when x is -3, and again, I'm using this, f of -3 would be -3 minus 2 squared, which is -5 squared, which is 25. Okay? If x is -2, f of -2 is -2 minus 2 the quantity squared, which is -4 the quantity squared, which is 16. If x is -1, f of -1 equals -1 minus 2 the quantity squared, which is -3 the quantity squared, which is 9. If x is 0, f of 0 equals 0 minus 2 the quantity squared, which is -2 the quantity squared, which is 4. If x is 1, f of 1 equals 1 minus 2 the quantity squared, which is -1 the quantity squared, which is 1. If x is 2, f of 2 equals 2 minus 2 the quantity squared, which is 0 squared, which is 0. If x is 3, f of 3 equals 3 minus 2 the quantity squared, which is 1 squared, which is 1. Okay? Are you all right with what I just did? Any questions there? Okay, well, I'll just keep going. If you have questions, stop me. All right? Now, to graph this thing, well, shoot, I either have to start all over, change my scale, or get a bigger piece of graph paper or something. But I want to look at something different, okay? Notice that these y values look like those. How did I get those? Well, starting at -1. So over here, -3 produced 9. Over here, -1 produced 9. Consider this, all right? Let's take a look at this. F of x equals x squared. What happens? I have an x value, I put it in, and I square it, and it comes out. All right? Now, let's take a look at this one. What happens there? I have an X value. I put it in, but then I subtract 2, and then I square it, and it comes out. So for this table, when I put in these X values, it changed things drastically because what I put in for X, then I subtracted 2. What if I made the inputs 2 larger than before? So that I'd put in a new input, I'd subtract 2. Wouldn't that take me back to the same value I had here? Watch what I'm saying, okay? Watch to see if this makes sense. Okay. All right. So let's see what f of -1 is. It's -1 minus 2, the quantity squared, which is -3, the quantity squared, which is 9. All right, we already know that from here, I know. In fact, let's just do this. Will you allow me to? Are you okay with me doing that, or do you want me to do all the calculations? Okay, let's see. F of 4 is 4 minus 2 squared, which is 2 squared, which is 4. And f of 5 is 5 minus 2 squared, which is 3 squared, which is 9. So by increasing my X values by 2 units to compensate for the fact that I'm going to subtract 2 units before I square it, my Y values are now the same as they were before. So let's see what this graph looks like. Okay, so now forget about that. Let's see what this graph looks like. -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, 5, 9. Look what happened. It shifted it to the right. How many units to the right? 2. 2 units to the right. Everything moved 2. Oh, to compensate for that. Okay. So here the vertex is at 0, 0. Here the vertex is at 2, 0. So a -2 inside shifted it in a +2 direction. Well, that's kind of weird. Let's go back. Okay. A +3 outside moved it up 3. A -4 outside moved it down 4. A -2 inside moved it in a +2 direction horizontally. What do you think this is going to do? What would a +4 inside do to the black graph? What would the red graph look like? It would move it 4 units in a negative direction. Let me prove it to you, okay? Let's find f of -7. F of -7 equals -7 plus 4 squared, which is -3 squared, which is 9. Oh, -7, 9. Oops. Sorry about that. My mistake. I plotted it at the wrong place. Let's get rid of that and that. Okay. It should have been here. Yeah, I didn't see that that's where the point was. Okay, so it's right there. If x is -6, f of -6 equals -6 plus 4 the quantity squared, -2 the quantity squared, 4. -6, 4 is right there, etc., etc., etc. Oops. Okay, so that's going to move it 4 units in a negative direction. All right, so let's review. When you've got f of x equals x squared, okay, it looks like the black graph here, it opens up. The vertex is at 0, 0. The axis of symmetry goes right through it at x equals 0. Okay, if you've got f of x equals x squared plus 3, it shifts everything up 3 units, including the vertex is now at 0, 3. If we have f of x equals x squared minus 4, it shifts everything down 4 units, and the vertex now is at 0, -4. If we go inside and we have an x minus 2, it moves everything to the right 2 units. The vertex is, look, the x value is changing now, and it's the inverse of what's there. Instead of -2, it's a +2, okay? X plus 4 plus 4 inside moves it 4 units to the left in a negative direction, okay? So in fact here, let's see, the vertex is at 0, 0 here, and here it's at -4, 0. Okay? What about this? Order of operations, you would square it and then apply the negative sign. Okay? So f of -3 is negative the quantity -3 squared, which is -9. F of -2 is negative the quantity squared, -2 squared, which is -4. Okay, so I'm squaring the x and then applying the subtraction sign. So it's going to look just like these, but negatives. What's that going to do to the y values if they're negative? It's going to take this thing and move it, flip it over. So it's going to look like this. Okay, the vertex didn't move, but the whole thing flipped across the x-axis. So if the coefficient of x squared is negative, the parabola is going to open down instead of opening up. If it's positive, it's going to open up. All right, what about this? What is the 2 going to do? Well, so f of -3 is going to be 2 times -3 squared. But what do you do first? Do you take 2 times -3 and then square it? Or do you take -3 and then square it? You take the -3 and square it, and then multiply it by the 2. So it's going to double all the values because this is x squared, and then times 2, you'd get that. So what does that look like? Let's see, -318, that's way off the graph. -2,8 is right here. -1, 2, 0, 0, 1, 2, 2, 8. So what does this look like? It's opening, I don't know, skinnier, or it's narrower, or whatever kind of thing. Okay. So what's going on there? All the outputs on the red graph are twice what they were on the black graph. Here the black is 1, the red is 2. Here the black is 4, the red is 8, because we're doubling the result of x squared. Okay. So what about this? Well, this is going to be 9/2, 4/2, 1/2, 0/2, 1/2, 4/2, 9/2. This is what? Just equal to 2, and this is equal to 0, and this is equal to 2. Okay, because we're squaring x, and then we're taking 1/2 times it. So then let's see, -3 is going to be at 9/2, which is 4.5. negative 2 is going to be at 2. Negative 1 is going to be at a half, 0, a half, 2, and that. So now this thing opens up wider. Okay, let's see. So here is the formula. It's the general form of the equations we've been looking at. Okay, now, so for instance, if I had y equals 3 times x minus 2 squared plus 5, okay? The vertex is going to be at 2, 5. Now, how did I get that? Okay, well, let's go back. Wasn't the x value the inverse of what's inside there? Wasn't the x value the inverse of what's inside there? So the x value would be the inverse of what's inside. And the y value is the constant outside. So in general, the vertex is at h, k. Okay? X minus h plus k. X minus h squared plus k. Okay? Now, the axis of symmetry goes right through the vertex. So the axis of symmetry is at the equation x equals h. If a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. Okay? Let's see if you're getting this. Let's say, let's go back here. Black, let's say we've got f of x equals x plus 4. Oops. X plus 4 squared minus 3. Okay, the axis of symmetry is at x equals negative 4, and the vertex is at negative 4, negative 3, and it opens upwards. Why? What's a? A is 1. There's an implied 1 there, okay? So the axis of symmetry is at x equals negative 4. That's a vertical line. It's dotted because it's not literally part of the graph. The vertex is at negative 4, negative 3. And this thing opens upwards, okay? Now, remember at the beginning of this whole thing, I started by saying when I'm not familiar with a particular function, I tend to use negative 3 to 3 as my inputs. Now that I know more information about the graph of this thing, here's what I'm going to do. I'm going to take the vertex and put that at the center of my table for the graph. Why? Because everything goes around that vertex. So negative 4, negative 3, negative 2, negative 1, negative 5, negative 6, negative 7. Okay? So I started with the vertex in the middle of the table. All right. So now let's find the rest of the graph. If x is negative 7, I'm using this thing right here. So f of negative 7 is going to be negative 7 plus 4 squared, whoops, minus, sorry about that. Slow down, slow down, slow down. Always got to keep reminding myself of that. Minus 3. Let's see, negative 7 plus 4 would be negative 3 squared minus 3, which is 9 minus 3, which is 6. Okay, so negative 7, 6. Is that right? Negative 7, 6 is right there. Okay. If x is negative 6, f of negative 6 equals negative 6 plus 4 squared minus 3, which is -2, quantity squared, -3, which is 4, -3, which is 1. So -6, 1 is right there. Okay. -5. F of -5 is what? -5 plus 4 squared minus 3, which is -1 squared minus 3, which is 1 minus 3, which is -2. Okay. Now, what about these values? Well, remember, there's symmetry. So wouldn't this be -2, 1, and 6? So it'd be here, here, and here. Now, but you don't have to take my word for it. Let's check it out. F of -3 is -3 plus 4 squared minus 3. Let's see here, which is what? 1 squared minus 3, 1 minus 3, -2. Oh, there it is. F of -2 is -2 plus 4 quantity squared minus 3, which is 2 squared minus 3, which is 4 minus 3, which is 1. There it is, etc., etc. So where's the vertex at? It's at -4, -3. Okay, so it's the inverse of what's there and obvious of what's there. Okay. Any questions about that? All right, I want to give you some more information. All right, let's say we've got y equals negative times the quantity x plus 3 squared plus 5, okay? Now, if we were to multiply this all out, so like FOIL it out, you know, take the x plus 3 times x plus 3 and FOIL it, and then distribute the negative sign, and then finally add the 5 at the end, what is the order of operations we would do? We would start here. We would start in here, right? Okay, so we deal with that first. Then we'd square it, then we do that, and then we do that, right? So that would be order of operations. Now, on the inside, we have x plus 3, okay? But on the inside, oh, inside, what did that do to the graph when we put something, when we change something on the inside, okay? What did this do? It moved the graph this way, didn't it? Along the x-axis, okay? Come on, what's going on here, folks? There we go. So it moved it along the input axis, okay? And did it do what we expected? No, it did the inverse. So like x plus 3, it's going to be a -3. It's going to go to a negative direction. Now, what about this, which is outside? Outside, that moved it along the output axis, that is y, and it did what was obvious. Okay, so that's my summary of the whole thing that's going on here. So let's look at what that's going to do. Okay, let's take this without all the scribbling marks. So we're going to have an axis of symmetry at x equals -3 and a vertex at -3, 5. Okay, what is this graph going to look like compared to the graph of y equals x squared? Okay, Let me just graph y equals x squared for a moment. Oops, I know, not so good. Okay. What's the x plus 3 inside going to do? On the inside, it's going to move it along the input axis, the inverse. So it's going to go what? 3 units to the left. You see that? Okay, so we're going to go that way. So we'll say -3, 3 units that way. Okay. What's this going to do? That's going to move it up 5 units. And what's this going to do? It's going to flip it over. So if we take this graph, in fact, let me see it. Let me do it this way, just to save some time here. Okay. Let's see here. Can you see that graph? That's the graph of y equals x squared. Okay. I'm going to apply all these shifts and things one at a time. So what if we have x plus 3 squared? See how it moved it to the left 3 units? Okay. Now let's see here. X plus 3 squared plus 5. Okay. Now what does that do? It moved it up 5 units. And finally, it flips it over. Again, I don't know if you can see that or not. But this thing moves it to the left 3 units. This thing moves it up 5 units. This thing flips it over. Okay. Now, that's a whole bunch of information, I know. But let's back off of that a little bit. Here's what you do need to know for sure. You need to know, let's go back here. Where was it? That when you have it in this form, actually, you know what? Let me just rewrite that. Okay. So you have y equals a times x minus h squared plus k. The axis of symmetry is at x equals h, and the vertex is at h k. If a is greater than 0, it opens upward. If a is less than 0, it opens downwards. Okay. Now, if you're graphing something like I've been doing here freehand on graph paper, then what you're going to want to do is what I did. Let's see here. Let's go back here where I found the vertex was at HK. So the inverse of that and the obvious of that. Okay. I put that at the center of my table. I went up by integer units, down by integer units, and found those points, plotted the graph. The axis of symmetry is a dotted line through there. Vertex is the low point in this case. Okay. That's if we were in a regular classroom graphing by hand, that is what I would have you do. Okay. But we're not. We're going to be graphing in WebAssign. And in WebAssign, things are very different in terms of what we need to do. So what I'm going to do right now, I'm going to, okay, so what I want to do is I want to look at how you do things in WebAssign. We're going to start off by just looking at this problem. Let's see, what is this? Problem number 10 there, okay? It says find the vertex and the axis of symmetry of the graph of the function. And the function is f of x equals the quantity x minus 1 squared plus 9. All right. So the vertex is going to be at HK. All right. And if we think of this as y equals a times x minus h squared plus k, then h equals 1 and k equals 9. So the vertex would be at 1, 9. So it's the inverse of the inside and the obvious of the outside, okay? This is where people often make a mistake. They write -1, 9, but it's the inverse of what's inside. So that means over here, it would be 1, 9, okay? And you can see the answer there anyway, right? Now, this next part is super important because I say it over and over and over again, and still when people take the test, at least half of them miss points because of this. The axis of symmetry is not a value. It is a vertical line. Therefore, the axis of symmetry is the equation of a vertical line, which is going to be x equals whatever h is. So in this case, x equals 1. But time and time again, I'll get students, they'll just put 1 in there, okay? And it's not 1, it's x equals 1. If you don't have the x equals in there, it will mark it wrong, okay? You've been forewarned. All right, now, do not graph the equation, but determine whether the graph will open upwards or downwards. What is a equal to? Well, there's an implied 1 out in front, right? So that's greater than 0, so it's going to open up. So you'd click on that one. All right? You okay with that? Let's do another one of those. Okay, so let's see here. We've got f of x equals, it looks like a tree or something. F of x equals -9 times x plus 3 squared minus 4. So the vertex is going to be at -3, -4, hk. Where am I getting that? Well, okay, think of this form. So if I've got x plus 3, but I've got to write it in the form x minus h, wouldn't h be -3? Okay, so the vertex is at -3, -4, and the axis of symmetry is at x, at x equals 8, so x equals -3. And again, you can't just put a -3, you've got to write x equals -3. Okay, so that's dealing with the vertex, the axis of symmetry. Oh, this thing opens downward, doesn't it? Because a is negative. All right, now let's talk about graphing. On paper, I would have you do what I showed you, where you take the equation, you'd find the axis of symmetry, you'd find the vertex, you'd put the vertex in a table, you'd go 3 values to the left and 3 values to the right, find those values and plot it and label things, okay? In WebAssign, to graph a parabola, you have to do 2 things. You have to find the vertex first, plot it, and then a second point, okay? But you've got to plot the vertex first. So let me show you how that works, okay? Let's say we have, what do we got here? The following equation. F of x equals x minus 1 squared plus 2. Okay? So the vertex is at 1, 2. So I'm going to come over here. I'm graphing a parabola. So I'm going to highlight the parabola shape. I'm going to click it until it turns blue. I'm not going to go with the points or the straight line, but the parabola until it turns blue. Then the first point that I plot, 1, 2, is going to be the vertex. Okay? Now I need to find a second point. Pick a value to the left or to the right. How about 0? Okay. Well, yeah, let's go with 0. So then if x is 0, f of 0 is 0 minus 1 squared plus 2, which is negative 1 squared plus 2, which is 1 plus 2, which is 3. So now I'm going to plot my second point, which is 0, 3. And there's the parabola. Okay. But you've got to plot the vertex first. Let me show you what happens if I don't do it correctly. I can take those same 2 points, but if I plot 0, 3, oops, over here, if I plot 0, 3 first, and then 1, 2, oh, look at there, it opened down. That's because it thought that that was the vertex, okay? Whereas in fact, it's supposed to open up the other way. So you've got to plot the vertex first. Okay, now, let's talk about if you're dealing with fractions. Let's say that you want to plot, let's just do this. Let's say that I've got some equation, and I'm not going to give a specific equation, but let's say the vertex is at 3/2, comma 4, okay? And then I have another point that's at 1, 6, okay? All right, now, so I come in here and I want to plot, let's see, the vertex is at 3/2, 4. That's like 1.5, 4. So I go right there. Oh, that didn't graph it where I wanted to, did it? Okay. Well, and then what? 1, 6. Oh, that's just messed up. Well, let's see if I go over here. 1, 6, and I plot that. Oh, I can fix it right here, can't I? My first point, don't use a mixed number, use a fraction. Okay? So just like when we were plotting linear inequalities at the beginning of this class, if the coordinates weren't nice and you plotted a point and it didn't land where you needed it to, after you finish the graph, you can go in here and you can change the value of the ordered pairs. Okay? Let's take a look at another one. Let's just, another example. Let's say we've got, let's see, functions. How about this one? F of x equals -2 times x minus 2 squared minus 4. Okay? The axis of symmetry is at x equals 2. The vertex is at 2, -4, and this thing opens downwards. Okay? Because A is negative, so it opens downward. The axis of symmetry is at x equals 2. The vertex is at 2, -4. Now, graphing it. So I'm going to come over here and get this to be blue. I'm going to go to 2, -4. Okay. I'm going to come back over here and let's, if I touch this thing, it moves. Let's see. 2, -4. How about 3? Let's put in 3. So f of 3 is going to be -2 times 3 minus 2 squared minus 4, which is -2 times 1 squared minus 4, -2 times 1 minus 4, -2 minus 4, -6. So my second point is 3, negative 6. I must have forgotten to graph that. I don't know. Let's see here. Okay. Now, is it going to let me delete this? Yeah, this thing isn't working the way I want it to. All right, let's go back here. We'll start here. Okay, so 2, negative 4, and then 3, negative 6. There we go. Yeah, the thing I usually use for this isn't working right now, so my apologies that things aren't always going the way they should. I tested it earlier, it worked fine, but oh well. So anyway, that would be the graph of this function. Notice the vertex is at 2, negative 4. It opens downwards. The axis of symmetry. Now, if you were graphing this by hand, you'd put a dotted line right through there. Okay. Let's take a look at another one. Let's see here. Yeah, this one's going to be awful. Let's do it. In fact, this isn't one they expect you to graph from the book, but just want to show you again what you can do with the tools available to you. Okay, so the axis of symmetry is at x equals negative 1/4. The vertex is at negative 1/4, comma 7/8. That's going to be tough to graph, isn't it? And let's find f of 0. F of 0 is going to be negative 3/2 times 0 plus 1/4 squared plus 7/8, which is negative 3/2 times what? 0 plus 1/4 is 1/4 squared plus 7/8, which is negative 3/2 times 1/4 times 1/4 is 1/16 plus 7/8. So this is what? Negative 3/32 plus 7/8. But that would be negative 3/32 plus, let's see, what do I need to do? I need to multiply 7/8 by 4/4. So that becomes 25/32. Wow. So another point is what? 0, comma 25/32. Yeah, there's no way I'm going to plot that accurately to start with. So here we go. I'm going to, vertex is at negative 1/4, 7/8. So negative 1/4, 7/8. It's about there. The next point is at 0, and then 22/32. Now let's put it there. Okay. So my first point is negative 1/4, comma 7/8. My second point is 0, and then 25/32. And there you have it. Okay. And again, I know that one was horrendous, but my point is, even if you get ugly numbers, you can manipulate them. Just get the points on there and then go in here. Don't use a mixed number. Don't use a decimal approximation. These are all things I tell students quarter after quarter, and they still do it. And then they don't understand why the graph doesn't work correctly. Okay. So there you have it. So for the weekend, you're going to do this first part of 10.4. On Monday, we're going to wrap up this chapter. We're going to look at a different way of coming up with the same information, the axis of symmetry, the vertex, graphing it. We're also going to look at how to find x and y intercepts and some applications, okay? But for now, over the weekend, section 10.4, part 1. Are there any questions before we adjourn? All righty. Well, then I will stop the recording.